nuclear reacts. That's made out of hafnium. Hafnium was the 72nd element, and transition metal with 72 protons and 72 electrons with 106 neutrons. Hafnium was discovered in 1923 by the Dutch chemist, Dirk Coster, and the Hungarian radiochemist, George de Hevesy, with the density of 13.31 grams per centimeters cubed with a melting point of 2504 degrees Kelvin and a boiling point of 4875 degrees Kelvin. Hafnium has an atomic weight of 178.49 atomic mass units and was named after the Latin word, Hafnia, which means Copenhagen. It has a brilliant silvery luster and is a member of the transition elements. The pair discovered hafnium by using X-ray spectroscopy on sample of zirconium ore. At the time of its discovery, hafnium was one of the two non-radioactive elements that had been predicted but had not yet been discovered. Hafnium does not exist in nature on its own, but is combined with zirconium to form minerals. Hafnium is found in the Earth's crust at around 5.8 parts per million. It reacts in air and forms a film to protect the sample. Because of this, hafnium is very resistant to corrosion. A very fine sample of hafnium can spontaneously combust in air. Hafnium compounds tend to be inorganic. At considerably high temperatures, hafnium reacts with several elements, including oxygen, nitrogen, carbon, iron, silicon, and sulfur. Hafnium readily forms compounds with zirconium. Hafnium is so similar to the chemical properties of zirconium that they are some of the most difficult to separate from a sample. Hafnium carbide has a melting point of higher than 3890 degrees Celsius, and is the most refractory compound known. Tantalum hafnium carbide has a melting point of 4215 degrees Celsius, which is the highest of any known compound. The high melting points of hafnium compound are being researched for possible applications in building materials that will be used at high temperatures. There are 5 stable isotopes of hafnium, and at least 29 radioactive isotopes. The nuclear isomer of hafnium was long regarded as a potential weapon. This belief is called the hafnium controversy, as researchers debated the possibility of the element triggering rapid energy release. Hafnium is used to create alloys with several metals, including iron, niobium, titanium, and tantalum. It is also used in nuclear reactors for its ability to absorb multiple neutrons. At the current rate of use, some estimates state that the supply of hafnium will be gone in 10 years. Stay tuned for tantalum.